Nuclear energy comes from the fission of an atom's nucleus. During this reaction, it results in a small amount of the loss of mass, according to Einstein's equation E equals mc squared, that converts this nuclear energy due to the bonds into a huge amount of thermal energy. In 1939, physicists Hahn and Strassmann discovered that during nuclear fission, it not only releases a huge amount of energy, but it also releases a bunch of neutrons, causing a huge chain reaction. And this reaction greatly amplifies the amount of energy that can be produced within one nuclear fission. Because of this, we've used this in several applications of technology. Essentially, what nuclear power plants do is they take the thermal energy harnessed from nuclear fission, and it heats up water, pushing steam through a very long, thin pipe. And then all this potential energy is used to push a giant turbine, creating a large amount of electrical energy without any emissions of greenhouse gases. With this huge amount of energy, you can see that a lot of people want to use it for bad intentions. Because of this nuclear energy, they put it inside a nuclear bomb. Because it doesn't need to be contained, and because it doesn't need to be that large, because such a small amount of uranium can be used to create a huge explosion. They considered this a very good idea, and they implemented this in Hiroshima during World War II. So, how exactly do these technologies work at an atomic level? Well,
nuclear fission involves breaking apart the bonds that hold an atom's nucleus together. These bonds are very strong, much stronger than the bonds that attract the electrons to the nucleus. When these bonds are broken, a very large amount of energy is released. But the question remains, how are these bonds broken if the bond strength is so strong? Well, nuclear fission for the purposes of energy production uses an element called uranium. More specifically, an isotope of uranium called uranium-235. Uranium-235 is quite stable as it is, but when you introduce a neutron to the nucleus, it becomes very unstable, an element called uranium-236. Now, soon after the neutron is introduced to the nucleus, uranium-236 will break apart. When it breaks apart, it releases a huge amount of energy. Along with the large amount of energy, a lot of neutrons get scattered from the nucleus. Now, these neutrons will then go on to hit other uranium-235 atoms, creating a chain reaction of nuclear fission.
Along with neutrons, many particles such as krypton and barium are released, which in turn give off alpha, beta, and gamma radiation when these two elements undergo radioactive decay. Therefore, these wastes need to be stored in a very safe place. The waste emits radiation for over 100 years because the isotopes have a very long half-life. Another problem with nuclear waste is that it can be used to make nuclear weapons. This is very unlikely, but it can happen. Also, those who work at nuclear power plants and live near nuclear power plants are at a very high risk of being exposed to radiation. Nuclear meltdowns have already occurred, such as the ones at Chernobyl and Fukushima power plants, hence they pose a great risk. Nuclear waste has an impact on aquatic life as well. Eutrophication is an ecosystem's response to the addition of artificial or natural substances to the ecosystem. This can cause a depletion of oxygen, thereby killing a lot of organisms in the ecosystem. However, in life, if nothing's ventured, nothing's gained. There are advantages to nuclear power generation. Nuclear power generation emits a relatively low amount of carbon dioxide when compared to burning of fossil fuels such as coal. Also, a small amount of nuclear material is needed for a large amount of energy to be extracted. And uranium and operating power plants is also relatively inexpensive when compared to fossil fuels.
Alternatives to nuclear energy include renewable energy sources such as wind energy, solar energy, and water energy. There are many pros to this, such as that it would be cheaper in the long term and it also produces cleaner energy. But a major con to this would be that it would be more expensive to create in the short term. An alternative to uranium fission is using thorium fusion. There would be many pros to this, the main one including that it's 4 times more plentiful than uranium and can be found in many places such as in rocks and soils. It is also cheaper to mine, however the reactors are a lot more expensive because all the nuclear power plants would have to be changed in order to use only thorium as a source.
In conclusion, nuclear energy provides many pros and cons for energy production. The pros obviously being that there is no greenhouse gas emissions. The cons being, however, that there is a lot of nuclear waste produced as a result of the fission. In conclusion, there will still have to be much more research done on nuclear energy to ensure that future generations have a clean, renewable source of energy.